Can we cancel it and do?
Go.
All right. Good morning, everyone. My name is Raj, and here's my team. This is Mir, Natalia, and Raghav. Together, we worked on this exciting project that combines data about real estate in Toronto. Our project focuses on predicting the prices of condo in Toronto using the advanced machine learning techniques. For the business insight, this could be a great project for a real estate developer. Who's looking to see the price of the condo. So our model predicted the price of the condo. Fuck. ये चूतिया हो गया फिर से sorry.
Go.
Good morning, everyone. My name is Raj, and I'm here with my team. This is Mir, Natalia, and Raghav. Together, we worked on this exciting project that combines data about real estate in Toronto. Our project focuses on predicting the prices of condo in Toronto using advanced machine learning techniques. This project could be very useful for a real estate developer. Our model predicts the condo price in which this price real estate developer can take and assess to build a building in a specific location. Next, Raghav will take on and he'll explain the EDAs for the project.
Yeah, thanks, Raj. So we first started by actually exploring our data set, understanding what are the relationships amongst our variables, the features that really define each building, each property, and the price. And what we started with actually understanding the price distribution in Toronto. We saw that Toronto had a big right skew, showing that Toronto had like a lot of houses clustered towards the 800,000 mark, but a huge number of houses also at very high values. And so that's a highly non-linear relationship that we want to explore more by actually digging into the variables. So next, we plotted each variable against all the others to see if there were any, beautiful linear relationships. And what we found was there were none. It was completely non-linear, barring one relationship between beds and prices, but even that had a high amount of variation. So that told us that we needed to use highly non-linear methods to analyze this data set. And so we started by actually cleaning our data set. What we did was we had to handle missing values. We had a bunch of other, values that were messing with our data set. So we started by dropping a lot of prices, and on the other hand, imputing a lot of feature values because we didn't really want to drop a lot of observations. And so we used mice for numeric data, KNN categorical imputation for categorical data, and through that we were able to recover our data set and build a good data set. So next, Natalia is actually going to explore the relationships based on this clean data set.
We first looked at the relationship between size of the apartment and price, and as one would expect, as the apartment gets bigger, the price increases. Next, we looked at price and maintenance cost, which have a very linear relationship. We also encoded for the beds to baths ratio, which is seen as the different colored dots. There does not seem to be too much of a relationship between beds to baths ratio and price or maintenance. We next tried to plot the data on a map of Toronto. On a macroscopic level, there does not seem to be too much of a difference between location and price. But if you zoom into the map, houses that are next to each other are similarly priced. This meant that we had to create a new local variable that encoded for the local average house prices and the local neighborhood count. Next, Mir will talk about the models we've used.
Um, so we started with fitting random forest regression, extra trees regression, and XGBoost regression, and then we fitted a neural network as well. Between the random forest, extra trees, and XGBoost, the random forest came out to have the least RMSE value. But after we fitted the neural network came on top. But the difference between the RMSE values between random forest and neural network were not that much. We also do some visualizations to better visualize our predictions, and we can see that most of the errors are in all the models are distributed around zero. We also came up with our own kind of metric for prediction accuracy, wherein the prediction is accurate if it's within 15% of the true prices. And we see that the random forest gave the best kind of prediction accuracy in this context with a prediction accuracy of around 0.7. With this, we would like to conclude our presentation. And as mentioned before, this is this presentation and this project will be very useful for various types of businesses, real estate developers, and so on. Thank you for listening.